to start our new unit, Unit 6, which is on ratio, proportion, and probability. 3 very important topics, not only for this class, but for the proficiency exam. We'll start with lesson 6.1, which is on ratios and rates. We're going to start talking about ratios first, and then we'll also indicate what a rate is and how we can use this in algebra. All right, consider Mr. Jennings' 6-period math class. It has 10 girls and 15 boys. And I want to compare the number of girls to the number of boys. So one way that I've written it right here, I wrote a colon in between. 10 girls, that was listed first, and then boys, 15 there. But we also write this as a fraction, 10 over 15, because in a fraction, we're probably a little bit more inclined to say, hey, I can divide top and bottom by 5, 2 to 3. So the ratio of girls to boys in Mr. Jennings' 6th-period class would be 2 to 3 in simplest form. We write ratios one of 3 ways. The ratio of 2 quantities. It can be written with the word 2 in between. It can be written with the colon, or it can be written as the fraction. Of course, the denominator cannot be 0. So here's an example. It says, write the ratio in simplest form of 16 to 40. Well, probably the easiest way for me to write something in simplest form is first write it as a fraction, and then look to see if anything might simplify by dividing top and bottom. And I'm thinking I can divide top and bottom by 8, and I get 2 to 5. I'm not going to say 2/5 as much as I'm going to say 2 to 5. That's how we indicate it's a ratio, by using that terminology. Now, my first example back here with Mr. Jennings' math class, I want to write the ratio of each, and I'm also going to simplify. I want to write the ratio of the number of boys to the number of girls. Well, in this case, we have 15 boys, 10 girls, so it would be 15 to 10. And again, dividing top and bottom by 5, I would get 3 to 2. And then in the second part here, the number of boys to the entire class. Well, there are 15 boys, but the entire class is made up of 25 students, so it would be 15 to 25, and then again I could divide top and bottom by 5 here, and I would get 3 to 5 as the ratio. Now at times we want to compare ratios to see which one is larger, which one is smaller. So probably the easiest way to compare ratios is either write them both as fractions, so that we can compare them as fractions, which we've done before, or even change them into decimals by dividing, because it's very simple to compare place value and decimals. Ratios that are equivalent ratios, equal value. Equivalent, you see equal value, 2 ratios that have the same value. Now I have an example here where we're going to use a table and we're going to compare some amounts here, since the table shows the amount on years of growth of 3 snakes at a zoo. Larissa, Sylvia, and Topaz there. Order the snakes in the table from greatest growth per year to the least. So what I'm going to do is I'm going to take the growth per year, so I'm going to write this as 4 is to 12. I'm going to write this one as 2.5 is the 5, and I'm going to write this one as 2.5 is the 3. Now those as fractions are a little tricky because they don't have the same denominator. If I was to divide, this would turn out to be 0.333, the 3's continue. This one turns out to be exactly 0.5, and this one turns out to be 0.8333, and the 3's continue. Well, you can compare these decimal forms much easier than the fractions, because you can look at the 10th spot to see that this is the greatest, then this one, then this one. You have 8 in the 10th spot, 5 in the 10th spot, 3 in the 10th spot. So in order, it would be Topaz, then it would be Sylvia, and then it would be Larissa, from greatest to least. Now, technically, what I have here are not true ratios, because I'm comparing different units. I'm comparing distance here, and I'm comparing time. So we have a name for when that happens, and they're called rates. Rates are similar to ratios, except a rate compares 2 quantities measured in different units. When you look at your odometer on your car and you're going 45 miles per hour, that's a rate. When they talk about you work at a job and you make $15 per hour, that's a rate, money per time. So a lot of times when you are looking at rates, you'll see these types of expressions: for each, for every, or per. Okay. Now the different rates, a lot of people want to compare things. They want to look at the unit rate, and they do that a lot with prices. If you go into a grocery store, you'll see various items, similar items, and they have different prices, but they're different sizes. So they give the unit rate on the typically on the counter there somewhere, so you can compare them, so you can see how much it costs per ounce or per pound or per package. A unit rate is a rate that has a denominator of 1 when expressed in fraction form. So I'm going to do an example with a unit rate here. It says in 1 hour, 4 club members assembled 320 newsletters. What is their assembly rate per person? Well, in this case, they assembled 320 for 4 people. So I need my denominator, where's it at? I need my denominator to be a 1. I'll divide top and bottom by 4. I get 80 over 1, or 80 newsletters per person. And that would be an example of a unit rate. Okay, let's find the unit rate here. We have 595 kilometers in 7 hours. We want to write this for 1 hour. So we're going to need to divide this by 7 to make this a 1, so we have to divide top and bottom by 7, so that we get 1 hour. Well, 7 goes into that, let's see, 8, 35, 5 times. And there's my unit rate of 85 kilometers per hour. Okay, remember, unit rate, the denominator is going to be a 1. All right, another example of a rate here. It says an insect crawls 1 foot in 10 seconds. At this rate, how far will it crawl in 5 minutes? So we want to know how far in feet it crawls in 5 minutes. Well, it's not a unit rate here. Now we're increasing the denominator from 10 seconds to 5 minutes. Now remember, 5 minutes, every minute 60 seconds, so that's 300 seconds. So to go from 10 seconds to 300 seconds, you would have to multiply by 30. So you're going to have to multiply the top by 30. And 30 times 1 is 30 feet. 3 more just like that. Write the equivalent rate. I have 5 meters. Oops, I've got to write down minutes here. I have 5 meters in 1 minute. Oh, actually, I didn't write minutes down. I meant to write down seconds here. 1 second. 5 minutes is 1 second. In 1 second, how many minutes? Meters. How many meters in 1 minute? Well, there are 60 seconds to a minute, so if I multiply this by 60, I'll get a minute. So 60 times that, 5 times 60 is 300. 300 meters per 1 minute. Here's another one. We see 20 cars in 1 minute. How many cars in 1 hour? Well, again, that key number here is 60, because 60 minutes make an hour, so I'd have to multiply this denominator by 60 to get 1 hour. I'm going to have to multiply this by 60. 20 times 60 is 1,200 cars in 1 hour. Over here, 5 pounds is for $1. How many ounces is that for $1? Well, there are 16 ounces to a pound, so if I have 5 pounds, I'm going to have to multiply by, to change it into ounces, I'm going to have to multiply by 16. 5 times 16 is 80 ounces for $1. Now this last example here goes back to the idea of ratios and equivalent ratios. Remember, they're equivalent if they have the same fraction form or the same decimal form, and I want to know if these are equivalent. 9 over 6 is 1.5 if I divide and write it as a decimal. 28 over 14 is 2 if I divide. And as you can see, they are not equivalent, equal in value. All right, well, be sure to look over the idea of what rates are and what ratios are, and look through these problems, and don't forget to practice, practice, practice.